Hi everyone, welcome to our sessions on Inferential Statistics. I'm Dr. Afif and today we'll explore how we use data not just to describe what we observe, but to make smart decisions and predictions about larger groups. If you're ready, let's dive in. Inferential statistics helps us make generalizations from sample to a populations. It uses probability to predict patterns and support our decisions in research. Think of it as a bridge between your data and a big picture. Remember, the main goal of inferential statistics is to make predictions or generalizations based on the sample. Let's clarify the difference between descriptive statistics and inferential statistics. Descriptive statistics just summarize what we see, like calculating the mean or median, but inferential statistics goes further. It asks, what can this tell us about the larger group? That's where tools like the t-test or ANOVA come in. Techniques like frequency table are descriptive, not inferential. Here are some essential terms. Populations is the entire group you're studying. Sample, a small part of that group. Parameter, a measure for the populations. And statistic, a measure for the sample. And yes, there's always some sampling error, the difference between your sample and the full populations. So you should know the difference between parameter or populations and statistic or sample. Some commonly used inferential tools include hypothesis testing, confidence interval, t-test, ANOVA, correlations and regressions. Each has its own functions, and we'll see examples of how they work. Say you're testing if extensive reading improves vocabulary in EFL students. Your populations might be all EFL students, but you can't study all of them, so you pick a sample of 30 students. If you test them before and after the program, a pair t-test helps you analyze the difference. So the pair t-tests are used when comparing some group before and after the interventions. Here's the roadmap for hypothesis testing. First, you should state your hypothesis, whether it is null and alternative. Set your alpha level. It's often 0.05. Choose the right test, like t-test or ANOVA. Calculate the test statistic. Compare it to the critical value or look at the p-value. And the last one, you have to make decisions whether you should reject or fail to reject the null. The p-value tells you how strong the evidence is. If the p-value is less than 0.05, you reject the null hypothesis. Your result is statistically significant. If it is higher, there is not enough evidence to reject the null. So you should remember that the p-value is less than 0.05. It means that you should reject the null. Let's say Group A learned through traditional method and Group B uses task-based learning. To compare them, you'd use an independent t-test since they are two different groups. So independent t-tests are for comparing two separate groups. A confidence interval gives a range of values where we believe the population's parameter lies. For example, a 95% confidence interval of 5.2 to 7.8 means we are 95% confident the true means falls between those values. To wrap up, inferential statistics helps us to generalize from sample to populations. Tools like t-test and ANOVA are the key. Always pay attention to your p-value, confidence intervals, and possible errors. Thanks for watching. Don't forget to check out the Google Form quiz to test your understanding. See you in the next video.